So this time's topic is time-dependent material for construction stage analysis in MIDAS Civil. So a little introduction for Benjamin Blasen. He is a professional engineer and is a very experienced engineer with more than 10 years of experience. He was a lead structural engineer at Puget Sound Naval Shipyard for more than 6 years. He also joined CH2M Bridge Group in 2015 and has worked on bridge engineering, load rating, and project management. He's currently at Jacobs at the Structural Engineering and Architectural Group. He's the lead of that group, and it's currently located in Corvallis in Oregon. So before we hand over the presentation to Benjamin, I want to give a brief introduction to MIDAS Expert Network. So in this network, for some of you who are familiar, you can attend to a webinar or become a webinar presenter. You can attend a smaller Q&A session, even for some one-to-one consultation for free. And in the future, we might have conferences, and we often post expert tips and tricks on our MIDAS Expert Network webpage. And yeah, there are a lot more benefit. And so how to join? You can simply go to this website, our webpage /MIDAS Expert Network. So it is totally free. We create this network because we want to have a better user community, and of course we want to get to know you more. And what we have to do is to fill out the form, and our team will contact you shortly. And sometimes, if you're stuck at your problem or just simply want a peer review, you can just also fill out the form, and yeah, we'll follow up with you. So without further ado, I'm just going to hand over the presentation to Ben. So yeah, I'm going to do that right now.
Okay, can you see my screen?
Yes, we can.
Okay, thank you. Yes, good morning, everybody. Thank you for joining. There's quite a few people on the line, and it's a reflection, I think, of the interest in this topic. It certainly is a topic that has been present with me throughout ever since I started doing bridge modeling in any piece of software, but certainly with MIDAS Civil. And I just want to say real quickly, thank you to MIDAS for the invitation and opportunity to talk about this subject. And a thank you to all of you who are listening in. Very much feel free to put in questions. I'm going to approach this topic from kind of a general perspective and give an overview. I think the general definition of applying time-dependent materials in MIDAS Civil is relatively straightforward. However, there's a lot of nuances about how you're going to use the results and making sure that your model is behaving how you expect it to behave. And so that's where I think we can kind of go lots of different directions and help people out with figuring out what their model is doing, depending on how you've defined the parameters and properties of those materials. I guess I'll also say that just to expand a little bit on the introduction, I have worked as a bridge engineer since 2015 and been in project management with Jacobs, formerly CH2M Hill. And if you do have other questions or comments, or you want to just connect about bridge engineering outside of the workshop discussion here, I'd be more than happy to do that. And my contact information will be available both, I think, through the MIDAS Expert Network website and then as part of this presentation. So let's jump into it. I'm going to give an overview of what time-dependent materials are, and that's just to define a little bit of background for us as we get into the discussion. If you are looking at this recording later on the web, and you just want some live demo of clicking through MIDAS, go ahead and skip forward. But we're going to do a little bit of background first and a step-by-step tutorial, and then get into the demo. I'm throwing some references up here on the screen just to give appropriate due to where I have pulled some material for this presentation. So what are the time-dependent effects for concrete? So when we're talking about a pre-stressed concrete model, and for any piece of software, but MIDAS Civil, the things that we're mostly concerned about are creep shrinkage and compressive strength gain with respect to time, and pre-stressing tendon relaxation with time. Those are kind of the main areas that I'm going to focus on. There's other things that you can do and other things that you can model with MIDAS Civil. You can do geometric and material nonlinearity. You can change loads and boundary conditions. You can stress external cables if you're looking at like backstays or a cable stay or a network tied arch, or you can do all sorts of other geometric kinds of interesting things. But I'm not going to get much into that. I'm going to kind of focus on our primary areas, the time-dependent material effects, creep, shrinkage, and compressive strength gain. So creep, we don't need to get too much into the structural engineering and material science, but we're looking at the increase in water cement ratio, increase in creep, and creep decreases in the age of the material, and similarly shrinkage decreases rapidly with time. So when we're looking at these definitions, the real critical thing to consider is what age of the concrete are you concerned about. If you're concerned with early age, so that 0 day to maybe 100 days of the material, then this analysis is highly critical. If you're doing something like a load rating where you're thinking about it in the very long-term behavior of the material, maybe this analysis isn't quite as critical. But there are certain cases where you would still want to do it. So that kind of segues into, well, do I really have to do this kind of analysis? And some of that question comes generally from the perspective that you can calculate losses directly for pre-stressed concrete, and there's code provisions for doing that. However, there's cases where you cannot do that, and AASHTO, as I've copied directly here, says for stage construction or multi-stage pre-stressing, you should do that in accordance with a time-step method. And a time-step method in the MIDAS Civil nomenclature just means construction stage analysis. So how do we do this? A construction stage analysis, just general overview, is using stages to control sequences, and that's the activation or deactivation of members, loads, or boundary conditions, or all three in any given step or stage. And this is relative to time, so an input of time in days. And I'm talking about a linear analysis only for this presentation. You can do nonlinear analysis with MIDAS Civil. But when we're looking at this, we're going to look at linear analysis, creep, shrinkage, compressive strength gain, pre-stressing tendon relaxation. And kind of the picture I'm showing here is a staged model where you have segments or sections of a pre-stressed beam or girder that is being built in sections and needs to be staged, analyzed. A general procedure here, and this would be true for any software that you're doing this kind of analysis in. It's very much true for MIDAS Civil. You're going to create a model with geometry, materials, sections, loads, and boundary conditions. You need to set up groups so that you can activate and deactivate those items appropriately, and then define your time-dependent material properties, link those properties to the appropriate material, and then create your stages and your control options. And then I like to always put this in here. You should always validate your output. You need to understand how the model is behaving, and especially when it comes to time-dependent properties, it's really easy to get results that do not make any sense if you've missed an input somewhere or you've toggled a switch that is telling the program to behave in a certain way that you didn't expect. And then once you've validated your output, you need to be able to combine the output appropriately in your load combos, and that means that you need to understand the load cases as they are set up by MIDAS Civil coming out of a construction stage analysis. In order to define our material properties for these time-dependent effects, you need to select what parameters are going to be used, what kind of curve is going to be used to define how creep and shrinkage and strength gain occurs with respect to time. And there are various models, we call it, or parameters that can be used. AASHTO allows you to use any of what I've highlighted there, and that's AASHTO parameters, the FIP model, which comes out of Europe, or ACI, or if you actually have test data available, then that's your best input, and you can user input exact values for the concrete that you're working with. I'll also note that in my experience, the FIP model behaves better and is a better representation overall than AASHTO parameters, and that's just mostly looking at a little bit of an over-conservatism with how much creep and shrinkage is estimated in early age with the AASHTO parameters. But I guess my recommendation is if you're having an issue with a large amount of creep and shrinkage strain, that you should investigate what the predicted forces are from these other models and the behavior that the other models give you to just kind of understand the differences between them. So like I mentioned, you can select these models and they are built into MIDAS Civil directly. So I'm showing a couple drop-down boxes here of screenshots from MIDAS Civil where you can select FIP code, you can select ACI code and others. If you're watching from somewhere besides the US, you'll see quite a few other options available within MIDAS Civil there. I almost exclusively use these built-in code parameters. It definitely makes it easier to build these, but you can user define as well. And understanding your results. So this is my last slide of kind of the background info, and then we'll get into the step-by-step where it kind of makes a little bit more coherent sense to see each step as they go. But I wanted to bring this up and provide it as a reference because sometimes there's confusion about what these load cases are and how to use them in load combos. And I think the most unique thing here is the way that MIDAS Civil will separate out a specific load case in a construction stage model if you want it to, and that's the erection load case. So you can define a load case that you do not want to be included in the dead load, and that's the erection load case, and that's most commonly, at least for me, used with like a wearing surface where I want to apply a different load factor than the dead load factor to it, and so I want it separated and to be able to control it separately. That's where that erection load case is very useful. Or if you have something that is applied during the construction stage process as a load, but you don't want it considered for final dead load calculations, and so maybe that's a temporary load case or it's a construction load case, etc. You can use that control for that purpose. And then you have your tendon creep and shrinkage primary and secondary forces, secondary in indeterminate structure, and each of those are separated out, but then there's also a summation, construction stage summation. So let's look at how this actually gets put together step by step. For reference, I'm using a model that is available to everyone who has MIDAS Civil. It's a MIDAS Civil tutorial. I'm selecting number 14, and you can find this in your program files under MIDAS Civil tutorial. And I did that because I feel like it's important for people to be able to follow along. If you're watching this as a recording, you'll be able to follow along and open that model and do the same things I'm going to do and see the same results. Because we're opening an existing model, we're not going to set up a model. And I think if you're looking for instructions on that, there will be other resources available for you. So we're going to jump right to assuming you have a model set up, and that's the geometry and loads and boundary conditions, etc. But we need to have groups, and that's so that you can control activation and deactivation in the construction stages. In the works tree, you can click over to the group tab, and you can see that in this model, this demo tutorial, groups have already been set up, and there's structure groups that have been labeled SG1 through 3, boundary groups BG1 through 3, etc. And so then those can be activated or deactivated in the construction stage control. Then we can define our time-dependent material properties, and it can be accessed through the ribbon, as I've highlighted, or through the works tree. Start with our creep and shrinkage material. In this case, we have the FIP code selected, a 5 KSI strength concrete, putting in a notional size of the member and relative humidity, and the age at the beginning of shrinkage. In this case, the tutorial has preset a 3-day age at the beginning of shrinkage. And what that is essentially doing is offsetting in time where you start on that curve. So you're not going to experience as much shrinkage as you would if you started at the day 0. And if you are concerned about early shrinkage and early creep, starting at 0 makes a lot of sense, but I would caution you that you need to reflect the reality of how it's being built in the field. So if you're starting at 0, what you're saying is that you're pouring wet concrete, and there's no strength, there's no stiffness of the member yet. And so if you have a member in MIDAS Civil that's defined that way, and it has its typical kind of, say, a pen roller simply supported member with 0 stiffness, 0 strength, MIDAS is going to behave that way if you start it at 0, and it's going to have a massive deflection and resulting forces, because you're going to, even just with self-weight, not have any ability to carry the load starting at 0. So if you're doing that, but you really want to see, okay, what are my creep and shrinkage values, then maybe you should think about also modeling the formwork or whatever kind of temporary staging is supporting that wet concrete in that condition. Or if that's too detailed of an analysis for that condition, then skip forward in time to where there is some stiffness and strength that has been gained, and that's moving that day forward. And that should also be reflected in your construction stage control for the day of activation. We'll see a little bit more of that when I get into the live demo here. Similarly, the compressive strength gain with respect to time model, you can select your model or code, and FIP is being selected here. And then you need to link those material properties to the material that you want it to apply to. And so what you need to think about this as is you are defining time-dependent curves, creep and shrinkage and strength gain with respect to time, but they don't necessarily apply to any of the materials that you have in your model. If you want them to apply to all of your concrete materials, they can, or some of them they can, or say you only want the compressive curve to apply, you can do that, or only the creep and shrinkage curve, you can do that. So you need to tell MIDAS which material it's applying to. In this case, I'm showing that it's being selected for your grade C 5000, and that both the creep, shrinkage, and compressive strength curves are being applied to that material. Then we can go and actually build our construction stages, and that can be launched from the ribbon or the little icon that's in the upper left of the model window. Add your stages as necessary. And again, there's other resources for more details on how to build construction staging. And then you need to do a real good job of actually validating the options on the construction stage analysis control for time-dependent effects. So anytime you're doing a construction stage model, you should come into this control data and validate that this options that are selected or pre-selected by default are what you want it to do and how you want it to behave for the construction staging analysis. Because there's quite a bit here that you can do or not do, depending on how you want to control your construction stage analysis. And for example, you want to make sure that time-dependent effects are included if you're doing a time-dependent analysis. You can add and modify your erection load cases here. You can tell it to calculate concurrent forces or not, and that's a big deal when you're looking at load ratings or other kinds of analyses where you care about concurrent force effects, say PM interaction of beam columns. You can also tell MIDAS to save output of current stages, and that's if you are, once again, maybe doing some sort of construction analysis where you're concerned about, say, a cantilever build of an arch with backstays, and you want to know at each step in the sequence and be able to export all of those analyses results, then you want to check that box so that you have all of those results available to you. And there's a lot of other things in here too, like the nonlinear analysis. And if there's questions that are specific to that, we can get into that at the end of the session. Like I mentioned, you should review your output from the ribbon or tree menu, click into the stages. And I'm talking not just about the final stage output, but go look at individual stages. And in this case, I'm looking at the fourth stage or step. This is actually a stage, the fourth stage. And I've scrolled through load cases. I'm looking at MY moment and axial and shear and validating that creep, shrinkage, etc. are looking like what I expect them to look like, that they're not drastically off in magnitude from what I would expect, that the shape of the moment diagram is appropriate, and that reactions and deformations are also what I expect to see. I think you will see something very quickly that is unexpected. For example, huge deformations would be an indication that you got something wrong, or zero for the creep and shrinkage forces would be another indicator that something's wrong. So maybe your time scale is wrong. And here's just an example of the moment output from this particular tutorial model, looking at that construction stage for the individual load cases. I just pulled out a few of them so you can see the moment diagram is pretty different between these different load cases. And then of course you have summation, which brings it all together. and then being able to use those and select those for your load combos. So when you go and build a load combo, you can click into load case, and all of those construction stage load cases are available to you. Generally, summation is used so that you can apply a particular load factor to it. And then an erection load case might also be selected to apply a separate load factor. Or maybe you're actually interested in individual load cases. So you can do all of that through the load combo control. Okay, so I'm going to switch to clicking through some of this live. I think there's a lot of value in just seeing how these controls work. So this is that tutorial demo model. I pulled it open. I'm going to unlock it just so that we can play with adding material properties. If I click over and see these groups here, I can see that there's groupings for control of activation and deactivation. If I click into defining construction stages, I like to scroll through and see that elements, boundaries, and loads are being activated and deactivated appropriately through each of the stages. And one of the ways that I validate models is to actually look at this through the query. I want to see that activations and deactivations are appropriate. And so from the query menu, group activation of construction stage, elements, boundaries, and loads are shown here. And this is a really quick way to make sure that everything you expect to be activated at the end actually is activated. And so you can see in this case, all of the loads are active at the very end. That's what that circle there means. All of the boundaries and not all of the elements. This structural lane support is not active. Okay, so then let's go and take a look here at our time-dependent material properties. So I can click into this existing one, or if I didn't have any there and I wanted to define a new one, I can go to the Properties tab from the ribbon. Click on this Creep and Shrinkage button. Add a new. And here we have this dialog where we can select the code and give it a name. And some properties. And then always click the show result to make sure you're getting a curve that looks like what you expect. So there's our creep curve and shrinkage. Okay. So now I've defined a second time-dependent material. And now I want to define a time-dependent compressive strength curve. So I can do that here from the ribbon, or I can come up here and go compressive strength. Sorry, that was from the tree. And then I clicked from the ribbon. Add. And we can do ACI for this one. Click redraw, make sure we get a curve that is appropriate. And it's worth noting time scale here. You can see 30-day strength is approaching our design strength. That makes sense. The early strength gain over the first 3 to 7 days is gaining the majority of the strength. That makes sense as well. Okay. Accept that. And now you notice over here on the works tree menu that these new materials that we've, or these new definitions we've created are highlighted in blue. And that's the MIDAS Civil way of showing you that it's not being applied to anything in the model right now. And that's because we haven't linked it to anything. So if I go click on Material Link, we have this option to link materials. And if I click from the material types here, we can see that those new definitions we added are now in the list. This test, creep and shrinkage curve, and this test, compressive strength. So if I wanted to now apply those to this material, I could. I don't think it'll let me apply them to a material that already has a definition. So instead, I could click this one and modify it. So now I've linked those new material properties to the concrete material. And notice now that the previously selected time-dependent material properties, the ones that are built into this tutorial, have now turned blue. Those are no longer linked and no longer active for the analysis. Okay, so now let's pull open this construction stage analysis control. And this is where we want to validate that the control options are what we expect. So yes, we do have time-dependent effects turned on. Let's click into the dialog and just make sure we have what we want. We are looking for creep and shrinkage. You can just do one or the other if you want. You can control convergence criteria if you are doing something that's very sensitive. You can increase or decrease tolerances. It's been pretty rare that I've found a need to change any of these settings. If there's specific questions on that, I guess we can get into it more, but I'll leave that for now. The default options here for output and state saving different force outputs are generally pretty good. I almost always turn on saving output of current stage down here. Otherwise, your default options here are going to be good for just about anything you're doing, unless you're doing something more sophisticated, like cable pretensioning or nonlinear analysis, which is available here. Okay, so that's really everything you need to do to define and apply those properties. And then once you've run your model, I'm going to switch models here to the one that is locked and already run, so you don't have to watch the run dialog. We can take a look at some of these results like I showed in the PowerPoint slide. So you'll notice that this dialog here is selected to post-construction stage by default. So if you want to see what's happening at individual construction stages, you need to click in here, and that gives you the opportunity to do that. You can click in this case I've gone to the first stage. The load case that's selected by default is summation. Maybe I want to look at dead load, moment. Let's turn on the legend. I'm in units of kip inches. I go to kip feet, and there we have a moment diagram for construction stage 1. Let's go to 2. We can see it changing because it's adding a segment there. Maybe I want to look at what the tendon forces are doing and validate the creep and shrinkage. So this makes sense to me because we have creep occurring in that first stage member, but not in that second stage member yet. So if I go to the next stage, I should see that picking up in the second member, and it's not in the third. And then similarly, if I go on to the final stage, now that creep is occurring along the full length. Okay, so once we feel good about how the model is behaving, we can click into the load combination button up here. And you can either have MIDAS do a setup for you of load combos if you would like, auto generation, which works well, or manual generation where you can come in here and select individual load cases. For example, maybe CS, summation, maybe this is what I'm going to build DC case from, and apply a load factor to it. And then whatever other loads that I want to add, etc. Okay, well, that was a general overview and not too much in depth, but I want to leave plenty of time for questions because I know that there are specific things that give people trouble. Maybe before we do that, one more thing that I'll look at here in construction stage control is these duration definitions. So this works in the timeline along with your creep and shrinkage curve. When you define your element activation, you can give it an age at activation here. And what that does is you can move it forward in time or time scale along that curve. So if I want to say that essentially it has started at age 5, that's what this definition is doing here. If I wanted to start it at 0, then I would need to modify it like that. That gives you the ability to control the relative strength and stiffness of the member with respect to time as you are activating individual elements. Then of course you have your duration of the stage. So if I start at 0, that means it's going to go through a 30-day duration of creep and shrinkage before it gets to the next stage. Or maybe I'm not that interested in the first element. Maybe I make this a 3-day duration and I start it at a 30-day strength. And that might be for looking at other force effects like boundary condition changes or something of that nature. Okay, I think I will stop there and open it up for questions.
All right, thank you so much, Ben, for your demo and your presentation. So yeah, like construction stage analysis has always been a very big topic, and it's always getting very tricky when it involves time-dependent material. So yeah, it's very great to see, like having a presentation of like the two combined together. So yeah, and so thanks again for the audience to show up and to listen. And so now if you have any questions, you can click on your control panel. You can type in your questions, and yeah, and we'll try to answer these for you. So one question from Anthony, actually. So Anthony asks, can MIDAS handle variable notional thickness for variable depth members?
Interesting. Yes, I think so. And you can define multiple curves, but if you're talking about varying along the length of the member, I don't think I've come across that particular case before. So I would have to look that up and get back to you, Andrew.
All right. Yeah, so far, we actually only have one question from Anthony. But yeah, I was wondering,
Sorry.
Ben, if you do have any like real life examples from your engineering practice that like, time dependent material in construction stage analysis play a very important part, or like any recent projects that you're willing to share?
Yeah, absolutely. So time-dependent properties, of course, for a pre-stressed concrete bridge is always important. And I think one of the more interesting cases of that is arches that are stressed. You'll have to bear with me as I kind of pull that open.
Yeah, actually last week, no, the week before Thanksgiving, we actually had a workshop on pre-stressed tendons in arch structures. So yeah, that was also very interesting. I think the project was done by Michael Baker in Cleveland, Ohio. So you usually don't see a lot of post-tensioned arches because they're already pretty stable structures,
Yes, well, at least in the US. Switzerland has done a lot with stressing of arches because you can make them much more slender if you do that.
Right.
Oh, wrong one. Sorry about that. Yeah, and if anyone else has other questions while I'm going and looking for a good example to share, feel free to put those in.
Yeah, I think your presentation is just really easy to follow. So yeah, but if any of the audience have, maybe you couldn't think of any questions right now, maybe it's too early, yeah, you can always email me. My name is JC, and my email is jsun@midasoft.com. So yeah, if you do have any questions, and not necessarily from this topic, you can always email me, and either I can answer to you or I'll forward it to Ben or our technical support. So yeah, we're always here to help.
Yeah, I think this is a good example here. I'll pull it open just to share what an active model would look like in addition to that tutorial. And I apologize, I didn't have it preloaded for folks. A little bit of waiting there.
It's okay, we understand. Oh wow.
Yeah, so this is an interesting model where you have arches with variable thickness. Let's see if I can show here one of the tendon profiles. And then time-dependent materials are applied. And this is a good example because we have two different properties, an arch concrete and deck concrete. And we were interested in looking at how they behaved independently of each other with respect to time. So codes have been selected, curves are selected for both creep and shrinkage and compressive strength. Those are linked accordingly to the arch and the deck. And if we just see a separate concrete is applied there, material to the arch and columns versus the deck concrete. So that's a good example of where there's an interest in applying multiple different time-dependent properties because there's a difference in concrete. They're going to behave differently with respect to time, and that differential could cause additional forces because of differential movement between them, differential deformation.
I see. So for this example, do you take into consideration the effect of primary creep shrinkage and secondary creep and shrinkage?
Yeah, I believe we did. This has been a little while now.
Actually, a question from Hadi. So he was wondering, what's the difference between the primary and secondary creep and shrinkage?
Yeah, secondary is the force effects in the indeterminate structure versus, let me pull open that slide again just to kind of have it on the screen while I talk. So your primary is the strains, but then in an indeterminate structure, you have secondary forces that develop over time, and that's what that is captured in that load case. Thanks for the question, Hadi.
So do you have any examples for the indeterminate structure?
Yeah, well, I think we could see them in this model here. If we look at one of the later load cases, look at primary first. I'm going to switch it to diagram so it loads quicker. And let's turn on a max value. It's hard to see. So we're getting 2,400 kips axial force from creep primary. Let's look at creep secondary. And these are relatively small. Let me decrease the scale so we can see a little bit better picture of what's happening. So what's happening here with this secondary is a little bit of that differential between the creep that's occurring in the deck versus the arch ribs. And what you can see is some compression happening in the deck, whereas the arch rib looks like, I can't quite tell how that's deforming. But that's very different than just the longitudinal creep and shrinkage that's happening with the primary force. This is that interaction of the overall indeterminate structure versus primary is that longitudinal creep and shrinkage that's typical of the member. The primary should be significantly more, but there are cases where secondary forces are huge. So it's good to look at both. There's shrinkage, and that looks like a similar behavior to what the creep secondary looked like. Let's look at shrinkage primary. And much more significant, of course, at least for the arch ribs. But what that shows me is that the secondary forces maybe would be significant in this case for the deck, because that's having an effect that there's a differential between the properties for the deck and the arch ribs with respect to time.
All right, gotcha. And so you have mentioned the imaginary force that MIDAS create to evaluate primary creep and shrinkage. Do you mind elaborating on that imaginary force a little bit?
Yeah, so when we're looking at these outputs, that imaginary force is the force that's necessary to create the deformation, the creep strain, or the shrinkage strain. Because we're not calculating that strain directly in the sense of a deformation, it's calculated using a notional or imaginary force. And that is the method by which MIDAS is actually calculating those strains. Is that kind of what that question is getting at?
Yeah, yes.
Yeah. I believe there's a write-up in the MIDAS user manual regarding that exact calculation methodology.
Right. So Ben just mentioned the MIDAS Civil user manual. So through a lot of actually interaction with the users, sometimes I realize it's kind of hidden. So either you can, just go up to the top right corner of MIDAS Civil interface, you can just get to the user manual, or it's actually built into your computer. So if you just go to your C drive and go to MIDAS and go to MIDAS Civil, you're able to scroll down and there's a file that is MIDAS Civil's user manual. So yeah, these are a couple of ways that you can locate it. And as Ben has also shown in MIDAS Civil file, you can find a lot of built-in tutorials that, if you don't have internet or just, want to do something on your free time, you can just practice on these tutorial files. Yeah.
Yeah, thanks for mentioning that. It is helpful that it is already pre-installed on your machine if you have MIDAS installed, and you don't have to go searching on the web to find these. They are available on the web as well, right?
Right. Yeah. If you just look up, MIDAS user manual on Google, it should jump out.
Mm-hmm. Yeah, this is one of the resources I refer back to fairly often.
Awesome. All right. Yeah. So it seems like we're approaching ending time, and yeah, I really appreciate your time, Ben, and our team was really, we really liked their presentation a lot. It's really easy to follow, and it talks a lot about very interesting topics. And also for the audience, yeah, it's very early in the morning, so we really appreciate you showing up and listening and asking questions. If you don't have any, if you do have any questions afterwards, feel free to let me know, and I'll forward that to Ben. So Ben, do you have anything else to say before we close it up?
Nope, just thank you so much and have a great day, everyone.
Thank you, Ben. All right, I'm just close up the session. Have a good day, everyone, and please stay safe.